Get going here. My name is Dick Martin.
Hi, Dick.
Everybody hear me?
Yep.
I'm with the Road Recycling Council of New England. I'm responsible for Maine, New Hampshire, Vermont, Massachusetts, Connecticut, and Rhode Island. I'm not selling you anything, so don't get nervous. I've got nothing to sell you. I'm just here to give you information, technical information on a procedure to repair failed road bases in place. Maybe what we're going to do is go through an agenda. I'm going to try to define FDR for you, the advantages of FDR, some candidate roads, the construction process, and if we have time, I know we're a little short and I can start a little late, so I'll do my best. If we have time, questions. If not, I'll be out down at the boat all day. If anybody in this room is responsible for any roads that look like this, all like this, or even like this. All those roads are in Rhode Island. I'm not going to say which towns because I don't want to cast stones at anybody, but it could be any town. Not only Rhode Island, Massachusetts, Connecticut, Vermont, they all look like this. All of the older roads. Well, what are we to do? Before, there was only one option, remove or replace when the road got to that condition. We're going to define full depth reclamation. It's a rehabilitation technique to remove full thickness of asphalt in a predetermined portion of the underlying materials, uniformly pulverized and blended to provide upgraded homogeneous material. What's that mean? We're going to take a portion of what's left of the asphalt and a defined portion of the subbase, or right underneath that asphalt, grind it up. We're going to add some cement to it, and we're going to come out with a road base that looks like this. Previous is how you had the opportunity to repair the base was go in and remove and replace with materials. Trucks are coming, trucks going. We're talking about doing this in place, and you'll be done in a very, very short period of time. And I'll pass this around.
Doesn't salt eat cement?
First of all, this is not concrete. So take off your concrete hats, throw it away. This is not concrete. This is a gravel material, and we're going to combine the base. We're going to stabilize that base using Portland cement. And as we go through, I don't want to not answer your question, but if the question is still there at the end, I'll be happy to answer it. So I kind of throw it up on the table right now, but I will get to it. Now, when we talk about cement-based materials, typically everybody, as soon as I say it, everyone says, oh, concrete. Well, there's a difference between concrete and cement-based materials. Roller compacted concrete and conventional concrete are very, very high in cement. There's a lot of cement in that. And conventional concrete is also high in water. Roller compacted concrete has a minimum amount of water. When we get into the cement gravel materials, which is soil cement, FDR with cement, cement treated base, cement modified soil, and flowable fill. The ones on this side are low cement factors and low water factors. Flowable fill, which is a gravelly material, has a high water content. So when we're looking at a gravel, the FDR would have very, very similar properties at the end as flowable fill, other than the fact there's not as much moisture in it, there isn't much water, and a lot less cement. Some of the advantage of full depth recycling, we can eliminate base and surface problems simultaneously. We can improve the load-bearing capacity of the road. We can keep the same profile. In our widening projects, we're going to have a uniform material curb to curb without bringing in any other material. Now, the economical advantage is that you're going to cut costs by using the asphalt that you've already paid for. We're going to use that as an aggregate within the base that we're reclaiming. We're going to save time by using in-place construction methods. We're going to minimize traffic disruptions. We're going to keep that road open while we're working. I say we, the contractor. I don't do any construction. I'm going to help you write the spec and get on board with the contractor, and then it'll be up to you, the town and the contractor, to do that. But the contractor will minimize traffic disruption. They'll keep that road open while he's repairing it. And there's no aggregate going back and forth. Typically on a job like that, you're going to have to repair the base. You've got trucks coming and going with material going, new material coming. we're not going to have any of that. There's no material to dispose of, so we're going to save a lot of energy in this project. Some of the candidate roads that we're looking at, obviously the ones that we saw first, roads with surface and base distress, roads that need to be improved by load bearing capacity. A lot of the development going on now, some of these older roads are turned into connector roads to either shopping centers or industrial parks. Before they were like cop paths, now they're secondary highways. So you're going to have to increase the load bearing capacity of that. This is a great way to do it in place and very quickly. Widening projects, some of these older roads that don't meet today's standards, it's a lot easier to widen them with this. Upgraded gravel and dirt road. And any special projects, extreme projects where you've had a road failure that you need to repair very quickly. Any place where you have a high amount of fines where there's a lot of pain. We don't have a lot of clay in New England, but in Texas they use a lot of this because they have that expansive clay. So they will neutralize the clay using a percentage of cement. Anywhere there's moisture problems, the cement stabilization will act to make the base more impermeable so we don't get water going through it, keeping the chlorides out. Does that answer your question a little bit?
Yeah.
Okay. And our heavy traffic, any place where there's heavy traffic, or potential of rutting, if you've got a weak base, we're going to strengthen that base so that there's going to be less rutting. And any place where you have non-uniform materials, very similar to those first pictures, we got a lot of patching going on. There's a lot of dissimilar materials. We're going to combine that base. Now, there's different types of stabilizers. Polar cement is not the only stabilizer. There's foamed asphalt, asphalt emulsion, calcium chloride. But when we're talking about strengthening the base, polar cement will add the most strength to that base repair. Now, the construction process is very, very simple and it's very fast. First of all, we're going to go out to get a mix design. You say, oh boy, here we go with that concrete talk again. The mix design is we're going to go out and take a sample of the roadway, including the asphalt. Typically about 100 pounds is enough. We're going to take it to a materials lab of your choice. Any materials lab is very familiar with any of these processes. These aren't secrets that we hold. These are standard ASTM testing. They're going to go in and they're going to do a gradation. They're going to crush up the asphalt and mix that material all up. Now, if you've got a roadway that say has 4 inches of asphalt on it, we're going to take a sample of 8 inches of the roadway. 4 inches of the asphalt, 4 inches of the underlying material. So we're kind of looking for a 50-50 blend of the asphalt and the underlying material. Now, you may ask, well, suppose we've got 8 inches of asphalt. Well, you're not going to do a 16-inch reclaim. So you're going to have to mill off some of that asphalt first. Probably 4 inches so we can get to that 4 and 8, or a 5 and 5 would probably be okay. Then we're going to take that material, mix it up, and this is really a technical end of it. We're going to try to determine how we're going to mix in, how much cement we're going to mix in, so that at the end of 7 days when we do these tests, that we have about 400 psi. Anywhere from 300 to 500, but we want to be in the area of 400 psi in 7 days. Now that's not exact, so we're going to use our really technical know-how that we have, and we're going to do 3 tests. One with 3%, one with 4%, one with 5%. And whichever one comes closer, that's the one we're going to use. So that's really technical. We're going to run a moisture density curve because we want the moisture in the field. The moisture in the field will typically be somewhere between 5 and 7%. But we have an optimal moisture where we want to be when we're out there doing this procedure, which is probably going to be somewhere in the vicinity of 11%, somewhere in there. And that's where we want to be. So when they do this test, they'll run this at optimal moisture. And then we will do an unconfined compressive strike. This would be the optimal moisture curve, moisture density curve, which shows it at about 11%. Now the unconfined compressive strengths are basically what they are as concrete cylinders. And we're going to make those cylinders using we're going to do three different samples using 3 different dosage rates of cement, percentage-wise. And then we're going to do 7-day breaks. 5% may come out at 600 psi, and we're going to say, no, that's too high. We don't want that much cement in procedure. But we want to be somewhere in the vicinity of 400. Now, if you've got one that's 450 and one that's 350, I hate to say this to you, but I might go with the one that's 350 because we're going to get the same performance, but we're going to have to use less cement. Now, less cement, in this procedure, more cement is not better. The more is not the better. We're going to try to get between 300 and 400 using the least amount of material as we can. So the construction process starts, they'll come in with a reclaimer. You guys have a reclaimer? No? I want to make sure, sorry. I don't want to forget you. They're going to come in and they're going to pulverize that mat. First thing they do, take all the asphalt, the underlying material, and pulverize it to a 2-inch minus. We'll get a gradation that looks something like this, depending on where you are or what's underneath the material that we find in those original cores. Now the grinding machine, the wheel looks very similar to this. In fact, this is it. The teeth will break up that asphalt. Usually on the jobs that we've been on, the asphalt is so bad, we'll probably break it up with a butter knife. But inside the reclaimer, it looks like this. We have the reclaimer runs in counterclockwise motion. We're going to grind up that material. It's going to be spit out the back. We also have a place where we can inject moisture into it should we need to. And if during the process of testing and finding out what we need for a mix design, we find that there are just too many fines in this to make this work, we can lay a layer of aggregate over the surface before we grind it, so that as we're grinding it up, we're working that aggregate into the base. After we grind it up and it's all ground up, we're going to come and split the cement. Typically, in New England, the dosage rate is 4%. 4% by volume. I can see someone out there that looks confused.
Who is it?
I don't know. Maybe it's me. 4% cement. Now, as far as spreading cement, there's different options. As you can see, this is a standard tanker. What they have is what we call a spreader bar in the back of that. It's just hooked up. The tanker rides down the street at a predetermined speed. Typically, we'll charge the tank to anywhere between 13 and 15 psi, and we will get the cement to flow out the back like that. Now, believe me, it's never that clean.
Is that powder or liquid?
That's the powder. That's a great question, because we're going to come to the liquid in a minute. It's a great question. So this is never this clean. So if you're in a residential area, give me a call, because we're going to have to come up with an alternate means for putting the cement down. This is what was referred to as a spreader truck. You'll probably recognize an old fertilizer truck. It's been reconditioned and reconstituted. It is computer designed so that we can drop the correct amount of cement. It's a much, much cleaner process. This one over here is also a dry process. This is a converted box trailer that they've done an awful lot of work to. There's a back system on the back, a dust collecting system. This, as far as the dry system goes, this is the cleanest method I've ever seen. You wouldn't know they were spreading cement if you were on a job doing that. This method up here is the slurry method. They're going to put it down wet so that there is no dust, nothing. The cement is spread on the top of the roadway, and then the reclaimer will come back through and mix that in. This is a picture of this vehicle. This vehicle happens to be have to go over the road empty. You can only work on a job because it's overweight, over height, over everything. So just get it to the job and it'll work with it. The slurry method. There is a contractor from New York who does use the slurry method, not this particular type. This picture happens to be from Texas. They use this a lot in Texas, the slurry method. This is the integrated slurry mixing process. You can see everything all in line. They get the reclaimer, the cement, the mixing truck, the cement truck, and a water truck, all in a line. They're doing everything all in one sweep, and everything is going to be done. This is a great process if you have a long road with no curves. As you can see, that train is relatively long. Also, when they have to close down the road at certain points when they have to bring either the water truck up on side to recharge the mixing truck. It's a great process. So if you have a long road, it does work great. These are the different types of reclaimer. This also is the water tank charging and mixing in the cement and adding moisture at the same time. This is just a little bit of a small reclaimer that went on the back of a tractor, and the typical reclaimer that we see a lot. Now, as far as blending in moisture, you can either blend in moisture through the reclaimer, or you can do it this way, using a standard water truck to add some water in. You really can't add too much water to this material. What happens if you do it just becomes a little bit unstable, and what that means is you have to wait a little bit longer. The town doesn't care about that. The contractor will go bananas about that because at this point, time is money. You better wait if you get it too wet. We'll go back in. We'll grade it. Material is graded to the appropriate plane line. Cross sections. Excess material is removed from the roadway if there is any excess roadway. On those roads we looked at earlier, we had pictures of. I would expect there would be no excess material because of all of the rutting and degradation of that roadway. We're going to use that material somewhere in the road, and by the time you get to the end, there's not going to be much left over. And if there is, a lot of towns like to take it back to their yard they use as a gravel fill later on. And look, when it compacted, typically we'll make a sheep, first passes with a sheep's foot. And then we're going to test the density of that product. I can tell you that almost, I hate to say 100% of the time, but I will, we're going to be in excess of 98%. When we get through and everything is done, we're going to want to keep that thing wet until we get either get the bituminous compound on top of it, or we get that base layer. Testing. We're going to do moisture tests in the field, and also densities. And as far as the frequency of testing, that's really going to depend on what we specify up front. As long as the contractor knows going in what he has to do, there's typically never any issues. In this particular presentation, we're talking about 100 feet each lane. That's a little excessive. I mean, once you get those densities down with the cement, you know you have the right dosage rate of cement, the density is going to remain relatively the same all the way through. Surfacing. You can surface this with anything you want. Chip seal, asphalt, conventional concrete, roller compacted concrete. You can use a surface of your choice. And you say, man, well, you know, hey Dick, why are we going to do this in the first place? Well, if you've got a failed roadway that you're looking at to repair, and right now your option is to remove and replace, doing it in this process is half the price. I'm not going to tell you what the dollar is, but every time we've looked at it, towns come back and say, you know, that was half the price. But what's that mean? That means it gives you that much more money to use in asphalt. You can either do that many more roads or repair that many more roads. But using this to repair failed bases, this is not for every application. If you've got a road where you can go in and put a skin layer over the top of it, and that's going to repair it for the amount of time that you want to repair it for, then that's the way you should do it, because that's more economical way. But if you've got a road that has gone beyond its life expectancy, and you need to do something with it, I think it may be in your best interest to take a good hard look at this, because this is the most inexpensive way to repair that base. Typically, what will happen, the question was how long does it take for it to dry? Usually, what happened, we just did this summer, we did 28 lane miles on Route 101 up in Vermont. And we were doing 2 miles a day. And it usually took about, they do one lane and then switch to the other lane so you can put traffic on that other lane, by the way. And it usually took about 3 hours. Yeah, it really depends on the weather and the rain, obviously. Yeah, you're not going to go out there in a very, doesn't mean you can't do it on a rainy day, but if you're going to do it, you can't go out there in a day. Because what happens is the material becomes, it doesn't ruin it, but it becomes unstable. And it doesn't become firm enough to drive it. And then the contractor has to sit there and do this while ka-ching is going on because all the guys are standing there. So what we want to do is we want to get out there on a good day, preferably a typical concrete day, you know, foggy, misty, perfect day for working. And you can do this on the roadway. Now typically what will happen, you can pave the same day. If you're doing small sections, you can reclaim it, seal it, pave it, all on the same day. But what happens is, because we've repaired that base, some towns have gone to, I know you're going to hate this, some towns have reduced the amount of asphalt that they have to put over. However, you might like this. That allows them to do more roadways.
That bituminous liquid you put on top of the base after it's done, what's the purpose of it?
This is a tack.
Oh, so you need it before you lay it out?
Yeah, I would, yeah, and you should sweep this before you put the tack on down, because there's going to be a little bit of dust here, so you probably sweep it before you put it down.
The question I have was on a road that's a dirt road.
Yep.
Don't you want to use that wrap in there to make the base? There's no.
Well, that's going to
there's
depend.
no asphalt.
That's going to depend. That's going to depend on what the surface of the roadway is going to be following, if they're going to remain, and also just exactly what type of material is in that road. I would want to do a sample on that. We may call for some, may call for, of course, if we brought a stone, we want to make to repair that road. But on a dirt roadway, if you have any in your town, this is a great way to prevent the rutting in the spring. Because it really almost eliminates that. Gives you a good firm base to work on. And then, if you can't afford the asphalt, there's also a great firm base for chip seal surface after you run, you know, one of those dirt roads that you don't really want to maintain all the time. I shouldn't say that.
Low
traffic.
Just an overlay? That's it?
Yeah, they've done something. They have, well, let's put it this way. You do need a line. Depending on the traffic. I mean, what I've seen them use the chip seal for is they did the roadway into a ball field. It was really rutted and messy in the spring. They couldn't get in there, so they went in there, reclaimed it, and they did a chip seal. They didn't use any liner on that. They just did the chip seal right over. But that has a very, very low traffic. Yeah, if you're in a high traffic count, typically the towns have gone to a 2-inch binder with a 2-inch overlay. Some towns have gone to 2 and 1 rather than 2 and 2, because they find that the base, the improvement in the base and the improvement in the carrying capacity of the base allows them to reduce that wear.
What's the difference between just grinding the road, grading it, compacting it, and doing two and two?
That would be okay, but this gives you a permanent repair to that base. You're not going to have to go back again. Because if you just do it without using anything to combine the base, eventually you're going to have the same problem. The only thing that you've done by reclaiming it and using that asphalt as aggregate within that base, increase the aggregate. If you've got failed materials in there, those materials are still in there, you haven't done anything to repair those. So this is a quick, easy way to permanently repair that base.
Do you do a concrete base road?
Sorry?
Can you do that over a concrete
Yes.
base road?
Yes. Yes. Yeah, you can use a concrete, roller concrete, asphalt, chip seal, whatever you like. The wearing surface of your choice.
So what's your oldest road? Like how long?
Let's see, that would be about 25 years old, and I believe it's in South Carolina. The one's in New England. There's one in Hopkinton, Mass. There's a gazillion in Maine. How are they with the frost?
Yeah, the frost heaves coming through?
Actually, no, frost heaves, it reduces frost heaves because it's not going to allow the moisture to come up or go down. So as long as you keep the profile of the road off, moisture will roll off this road, and it can't get through the base. What we've seen up in Maine, because they're probably 10 years into this, they've had to replace some of the asphalt, but the base has remained okay. They haven't had to do anything to the base. Maine has done a lot of this. So the question to the salt should answer that. Where Maine is probably, well, it is. They've done more than Although Vermont is starting to catch up because they're doing long lengths of road up there. What do they call that? Rockies Kingdom of whatever it is up there. All I know is when I went up there to that road, the only thing that was up there with me and 3 boots. It was in the middle of nowhere. And that'll be it for me. If you've got any other questions, I'd be glad to answer them. You can stop by the booth. We had a road like this. And keep the same profile and make it look like that. If you have any questions, stop by.